So for this lesson, we're going to talk about factoring, and I will preface this with factoring is an essential skill for all of the maths you're going to do, Algebra 2 and beyond. So this is a lesson that if you struggle with any of these factoring methods, you really need to come back and try these additional examples. This entire answer key will be posted on Google Drive, so you'd be able to check yourself, but you really have to feel comfortable with all kinds of factoring, and that includes some of the trickier kinds of factoring, which we're going to get to a little later in the lesson. So we'll start with the easiest kind of factoring, which is called greatest common factor. And what you're looking for is the greatest number that divides evenly into every coefficient of every term in that polynomial. What's the highest power of any variable that goes into every term? And then obviously you want to divide that out. So as you take a look at the first example, 12x squared y cubed minus 15xy squared plus 9y. First, look at the 12, 15, and the 9 and ask yourself what goes into 12, 15, and 9. As you sit there and you play with your numbers, eventually you'll realize it's 3 that goes into all of them. So 3 is going to be part of my greatest common factor. Now you want to take a look. You have an x squared, you have an x, but you don't have any x's in the third term, so you're not going to have any x's in your greatest common factor. Let's take a look at y's. I have a y cubed, I have a y squared, and I have a regular y. So as I go through, what I need is the highest power of y that's going to divide evenly into every term. It's actually the lowest of the 3 powers. So out of y cubed, y squared, and y by itself is going to be part of your GCF. You're going to divide 3y now into each of your terms of your main polynomial. Let me move this down for a second. And once I divide 3y into each of these terms, whatever's left over goes in its own parentheses, and now you have factored that expression. So this comes out to be 4, x squared cannot cancel with anything, y cubed over y squared, you subtract your powers to get y squared. So then that comes out to be 5. There's nothing to divide with x. Y squared divided by y is just y. And then finally, those y's cancel out in the last term. 9 divided by 3 is 3, and that's your final answer. Keep in mind, there's a difference between simplifying and factoring. If I wanted to simplify this expression, my original problem would be my solution. Simple means no parentheses. Instead, I wanted to factor my expression, which means I want to have it in a form where it's 2 things being multiplied together. So obviously GCF again was like kind of the first introductory type of factoring. One of the other kinds of factoring that you should be familiar with is dots. So dots is difference of 2 squares. Difference meaning subtraction. If you don't have a difference of 2 perfect squares, you cannot do this kind of factoring method. So this is what people sometimes refer to as the double bubble method, something like that. You're going to take 2 sets of parentheses, okay? And you can see a squared is a perfect square, 9 is a perfect square, and there's a minus in the middle, difference of 2 squares. One gets a plus, one gets a minus. When you take the square root of the first term, the square root of a squared is just a. That becomes the first term in your 2 parentheses. When you take the square root of your second term, just the 9 by itself, don't worry about the negative, that comes out to be 3. And now that is my factored version. You'll have to be careful with examples where you have something like 4x squared minus 25, or even better yet, watch out for something like number 6. As I take a look at this one, if you take the square root of 16, you get 4. If you take the square root of 9y squared, you'll take the square root of each term individually. Square root of 9 is 3, square root of y squared is y. If you take a look at this, 3y plus 4, 3y minus 4. Is that the correct way to factor this expression? The answer is no. Even though I'm using the 4 and the 3y, the order makes a difference. So I'm going to cross this out. The correct way that I have to put this is 2 sets of parentheses, one's a plus, one's a minus. Since the 16 comes first, that means the square root of 16, which is 4, has to come first. And since the 9y squared came second, the 3y has to come second. Okay, this is not the same answer as the one that I crossed out, and the order does make a difference, so please be careful when you are doing dots. So now a common factoring method that many of you guys have probably worked before is trinomial factoring. When you're doing trinomial factoring, I like to refer to this as the AM method. Why is it the AM method? Well, first of all, a trinomial has 3 terms. That's what you want to first check. If that's the case, you want to find what numbers are going to multiply to your last term and are going to add to your middle term. AM is a way of helping remind you that you're adding to your middle term, A, and multiplying to your last term. So you're going to do 2 sets of parentheses. And you're going to put the square root of x squared, because that's my first term, as the first term in each of these parentheses. And now you're going to have to actually do a little bit of playing with your values. So now this one shouldn't be too bad. If you think about the numbers that multiply to be 12, I have 1 and 12, I have 2 and 6, I have 3 and 4. Which one would add or subtract to be a -1? Because that's my middle term there. It has to be the 3 and the 4. So you can sit there and say, is this going to be a -3 and a +4, or a -4 and a +3, right? So which one adds up to be -1? It's this bottom one, -4 and +3. That way you have two numbers that multiply to -12 and add up to be -1. If you get stuck, what you can do is you can go into your graphing calculator. So let me open this one for just a second. And if you go to y equals, so like for example, in the next problem, so let me do a little split screen on this guy. Okay, so in this example number 9, okay, again, I'm doing AM method. What adds up to 11, what multiplies to be 30, you're going to do two sets of parentheses. You're going to start with a as the first term because that's the square root of a squared. I need two things that multiply to be 30 and add up to -11. If you go to y equals in your graphing calculator and you type in 30, so the number you want to multiply, divided by x, okay? Because think about it, you would normally do 30 divided by 1, divided by 2, divided by 3 to see what divides into 30, and then take a look at your table. Okay, you can start always with where it says 0 and then work your way up. You can see that your factors are 1 and 30, 2 and 15, 3 and 10, 4 and 7.5. Once you get to the point where the left number is bigger than the right number, there are no new factors. Anything with a decimal doesn't count. And now you can sit there and say, okay, which of this combination is going to multiply to make a positive 30? Multiplying to a positive means the same sign. And they have to add up to make a -11. So as I look through, the ones that make 11 would be 5 and 6. I want them to be the same sign and they have to add up to -11, so -5, -6. Okay, so again, that was y equals, take the number that is your m, what are you multiplying, and divide it by x, and then take a look at the table, and that's how you can find some of the factors if that's something that you struggle with. Okay, I'm going to keep that on the side because I'll come back to that. Okay, don't be concerned with something like number 10. Okay, forget about the y to the 4th for just a second. This is still a trinomial, 3 terms. You're still going to do AM method. The only difference is when you first do your two sets of parentheses, you have to think about what is the square root of y to the 4th. The square root of y to the 4th is y squared, so y squared has to be my first term in each of these parentheses. You have to ask yourself, what adds up to -2 and multiplies to be +1? What multiplies to be +1, right, is going to be a -1 and a -1, okay? It has to be a +1 and a +1, or a -1 and a -1. I need them to add up to -2, so that's why it's -1. Then you need to ask yourself, and this is going to be important as we go forward with factoring, you have to ask yourself, is this factored completely? And the answer is no. Y squared minus 1 is Dot's problem. So I'm going to do two sets of parentheses, one with a plus, one with a minus. The square root of y squared is y. The square root of 1 is 1, and you're again going to repeat that for that second expression. You always need to be factoring completely, okay? So again, do not be concerned if it doesn't start with y squared or a squared or x squared. It's still 3 terms. You can still use AM method. So now we're going to get into a method called factoring by grouping. So if you take a look at this problem right here, technically I probably could combine like terms and do GCF, but I specifically wanted to do this problem because I thought it would make doing the tricky trinomials, which we're going to get to, a little easier and to help you to understand a little bit of factoring by grouping. The idea behind factoring by grouping is usually you would have 4 terms that you can't combine and you can't factor something out all 4 terms. So what you do is you basically think about, I'm going to make this a little tinier, you think about kind of chopping those terms in half, right? Focus on each half of this expression and GCF each of those halves. So I see, okay, 5a squared minus 5a, I can pull 5a out of each of those terms. As I divide 5a into each of these terms, I end up with an a minus 1. Be careful, 5a over 5a, that cancels out to be a minus 1, not 0. That's a big thing that people make mistakes on. In the second set of terms, the fact that there's a plus here, that's definitely going to come down. That pretty much always carries through when you do a factor by grouping. 3a squared minus 3a, you can pull a 3a out of each of those terms, and you'll have an a minus 1 left over. So now you should notice this parentheses is the same in each of those expressions. Okay, so you're now going to factor that parentheses out. So you're going to take out an a minus 1 from each half of this expression. So imagine dividing an a minus 1 into this half. You'd cancel these out. You'd be left over with 5a. Imagine dividing an a minus 1 into this half. As those cancel, you're left with a 3a. Now, normally, this would be the end of your factoring. In this case, 5a and 3a can be combined, and you'll end up with 8a times a minus 1. But normally, you would have been at a point over here where you would not have been able to factor any further. Okay, that was just a unique example just to get started. So let's try another example. So as I take a look at number 12, I have 4 terms. Okay, so it's not a dots, it's not a GCF, it's not a trinomial, 4 terms, and I can't factor anything out of all 4 of these terms. So let me start with doing it in half. So I chop it in half after the second term, and I'm going to GCF each half of this expression. As I look at those first 2 terms, I can pull out an a squared. As I do so, I'm left with a plus 1. This middle sign is always going to come down and be after the little split bar. I can factor out of the 2a minus 2, a 2. What's left over when I divide 2 into that would also be a minus 1, sorry, a plus 1. It's really important that you recognize these 2 parentheses have to be exactly the same. If you don't have the same parentheses in each half, you've done something wrong. Because now you're going to GCF that parentheses out of the expression. So I'm going to pull out the a plus 1. That's what's in each half of my expression. When I take an a plus 1 out of the first half, I'm left over with a squared. I'm going to bring down, I'm going to divide a plus 1 into the second half, and I'm left with minus 2. And now this is my factored version of that polynomial that I normally would not have been able to do without factoring by grouping. So again, chop it in half, GCF each half, take out the common parentheses, and put whatever's left over in its own parentheses. So how is this going to help you when you get into tricky trinomials? So what exactly is a tricky trinomial? All right, take a look at this example right here. Factor 6x squared plus 5x plus 1. Okay, first question you should always ask yourself, is there a GCF? Unfortunately, no. If there is, you had to take that out. Is this a dots problem? I don't have 2 terms, and they're definitely not being subtracted, so no dots. I do have a trinomial, but unfortunately, this 6 that's in the front of my expression is what makes this a tricky trinomial, so I can't just do AM method. But again, you will see some overlap of concepts from the last 2 methods we just did. So what we are going to do in these problems is we're going to find a way to split this middle term, to split up that 5x into either x and 4x, 2x and 3x. There's like a million different combinations that you can do of things that would add up to be 5x. But you don't want to just pick any random 2. You need to find a specific pair that's going to add up to a positive 5 and is going to multiply to whatever the product is of the first and last numbers. So when I multiply 6 and 1, that's my m, and my a is 5, okay? So things that multiply to 6 and add up to be 5. So as I think about those numbers, okay, I have to be careful because the 5-6 combination is a little tricky. I'll realize that I can split this middle term into a 2x and a 3x. Okay, so let's think about this for a second. Is it true that 2x plus 3x is 5x? Yep. Is it true that 2 times 3 is positive 6? Yep. That's how you know that's the right combination to split your middle term. Once you've split your middle term, you're going to carry down the first term, keep that exactly the same, carry down the last term, keep that exactly the same, and what do you know? I now have 4 terms. So once you have 4 terms, that's when you can shift to factor by grouping. I have these 4 terms, I can chop this in half, GCF the first half, I'll see that I can take a 2x out of the first 2 terms. When I divide 2x into each of those terms, I'm left with 3x plus 1. Bring down that plus, that always goes after the bar, whatever sign is here. Can I take anything out of 3x plus 1? No. So I'm going to actually think of that as a 1 outside, and I'm left with 3x plus 1 left over in parentheses. Just as before with factor by grouping, you should see a common parentheses in each half of your expression. So you're not going to pull that 3x plus 1 out to the front. Okay, so imagine dividing 3x plus 1 into each half of your expression. As you do that, you're left with a 2x and a plus 1. And now this is your final factored version of that tricky trinomial. So let's try another example, and then I'm going to leave the rest of these examples for you to try on your own. So take a look at this first one. 3x squared minus 4x minus 4. Here's the checklist in your head. Is there a GCF? No. Is this a dots problem? No. Is this a regular trinomial? No. Because of this 3 that's in the front, that's a tricky trinomial. That's how you know you have to do this tricky trinomial grouping method. So you're first going to think about the fact that you're still going to add to your middle term. That does not change. But instead of multiplying to the last term, you have to multiply the 3 and negative 4 together to become negative 12, and that becomes your m. So you're going to ask yourself, what multiplies to negative 12 and adds up to make negative 4x? Because remember, the idea is you want to split this middle term, split up that negative 4x. So as you do so, you can say, all right, let me think about this. 6 and 2, right? As I break that apart, I have 6x and 2x. I want that to make a negative 12, so they have to be opposite signs, and I specifically want them to add up to a negative 4. So that means negative 6x, positive 2x. Just so you know, if you wrote them in the reverse order, that's not a big deal. It's totally fine. Again, it's gonna end up in the same factors anyway. Once you have split your middle term, you're going to keep the first term up front. You're going to bring down the last term. That's unchanged. And now that you have these 4 terms, you're going to do factor by grouping. So I'm going to chop it in half. I'm going to GCF the first terms. Okay, I'll be left over with x minus 2. Bring down this plus. What can I GCF out of the second 2 terms? A 2. And what am I left over with? X minus 2. So once again, you should be recognizing you see the same parentheses in each half of your expression. You're now going to factor out that x minus 2, take whatever is left over, and that goes in its own parentheses. So 3x plus 2 now goes in its own parentheses, and that is your final factored version for number 14. As I mentioned before, factoring is a really essential skill for all levels of math. So if you're struggling with any of these concepts, rewatch this video, rewind and look at examples, and make sure you try the additional examples that are left on this worksheet.